Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC with side AB that equals to 8 units, side AC of triangle ABC equals to 14 units, and we also know that angle ABC, this angle equals to 2x, and angle ACB, this angle equals to x, and we want to find the area of triangle ABC. So we will start with the first method. Actually, we will draw a line segment AD in such a way this point will be point D, and actually we draw side AD, line segment AD, in such a way that this angle will be equal to 2x. Okay, so here we have in triangle ABD we have two angles that are equal to each other. Angle ADB equals to angle ABD. Both those angles are equal to each other and they equal to 2x. Okay, and we have a rule that states that if you have triangle ABC if in triangle ABC you have two angles that are equal to each other, if this angle is angle alpha and this angle is also angle alpha, so those two angles are equal to each other, then AB will be equal to AC. Again, if you have triangle ABC and two angles of triangle ABC are equal to each other, that is to say this angle ABC equals to alpha and angle ACB also equals to alpha, so those two angles are equal to each other, then AB equals to AC. AB, side AB of triangle ABC will be equal to AC. Okay, because in front of equal angles you have also equal sides. AC, side AC of triangle ABC is in front of angle alpha, and side AB of triangle ABC also is in front of this angle alpha. So the sides that are in front of equal angles are also equal to each other. So AB equals to AC. Therefore, in triangle ADB, we have two angles that are equal to each other, in triangle ABD, we have two angles that are equal to each other. Angle ABD equals to angle ADB. Both of those angles are equal to each other and they equal to 2x. So therefore, according to the rule that I mentioned, also AB will be equal to AD. Okay, so in triangle ABD, we have two angles that are equal to each other. Therefore, the sides that are in front of those two angles also are equal to each other. That is to say, AB equals to AD. AB equals to AD. Okay, according to the rule that I mentioned, also the sides are equal to each other, because in front of equal angles you have equal sides. AB is in front of angle 2x and AD is in front of angle 2x. Therefore, those two sides are equal to each other. That is to say, AB equals to AD. Okay? So, but we know it is given us in the question that AB equals to 8 units. Okay? It is given us in the question that AB equals to 8 units. Therefore, according to this equality, AB equals to 8 units, so we can deduce from this equality that AD also equals to 8 units. Okay, AD also equals to 8 units. Okay, so AD equals to 8 units. According to the rule that I mentioned that in front of equal angles, that is to say 2x equals to 2x, you have equal sides. AD equals to AB and AB equals to 8 units, so AD also will be equal to 8 units. Okay? And we have also another rule that if you have triangle ABC, so if you have triangle ABC, and this angle is angle alpha and this angle is angle beta, then we have a rule that states that the exterior angle, that is to say this angle, will be equal to alpha plus beta. Again, the exterior angle will be equal to alpha plus beta. Okay, again, in triangle ABC, we have angle alpha and angle beta. So, according to the rule that I mentioned here, the exterior angle, this angle, will be also equal to alpha plus beta. Okay, or this angle will be equal to the sum of those two angles. that is to say this angle will be equal to alpha plus beta. Okay, so actually we can implement the rule that I stated here in our triangle, because actually we have here angle DAC plus angle DCA must be equal to angle ADB. Again, according to the rule that I mentioned, angle DAC, this angle, plus angle DCA, that is actually angle X, will be equal to the exterior angle that is actually 2x, that is actually angle BDA, or we can immediately state that the exterior angle is actually 2x. Again, according to the rule that I mentioned, the sum of those two angles, that is to say angle DAC plus angle DCA, will be equal to the exterior angle that is 2x. Okay, so angle DAC, this angle, plus angle DCA, that is actually x, must be equal to the exterior angle 2x. Okay, angle DAC plus angle DCA will be equal to the exterior angle 2x. But we know that angle ACD equals to x. Again, I will write it again. Angle DAC plus angle DCA equals to 2x. This angle plus this angle equals to the exterior angle 2x. But angle DCA, this angle, equals to x. It is given us the question. So angle DAC plus angle DCA, this is angle DCA, this is angle DCA, and angle DCA equals to x. So the sum of those two angles equal to the exterior angle 2x, according to the rule that I mentioned. Okay, so here we can subtract x from this equality, and we will get that angle DAC, equals to 2x minus x is x. So angle DAC equals to x. Angle DAC equals to x. Okay, so this angle is also x, and this angle is also x. So in triangle ADC we have two equal angles. Okay, in triangle DAC we have angle DAC that equals to angle DCA. Angle DAC equals to angle DCA. Again, in this triangle ADC, those two angles are equal to each other. They are equal to x. Okay, in triangle DAC, angle DAC equals to angle DCA. This angle equals to this angle. And according to the first rule that I mentioned, in front of equal angles, you have equal sides. So if this angle X is in front of AD, then this angle X is in front of DC, so those two sides are also equal to each other. That is to say, DC equals to AD. According to the first rule, we can deduce that because of the fact that we have in triangle DAC two equal angles, they have also, in this triangle we have two equal sides. That is to say, DC equals to AD. Okay? Whenever we have in triangle two equal angles, we always will have also two equal sides, because in front of equal sides or in front of equal angles we have equal sides. So AD is in front of X and DC is also in front of X, so those two sides are also equal to each other. That is to say, DC equals to AD. But we know that AD equals to 8 units. Okay, AD equals to 8 units. We found out that AD equals to 8 units. So from this equality, that DC equals to AD equals to 8, we can deduce that DC also equals to 8 units. Okay? From this equality, we can deduce that DC equals to 8 units. Okay? DC equals to 8 units. Okay? DC equals to 8 units. So here we can write that DC equals to 8 units. Okay? So actually triangle ABD is an isosceles triangles. Triangle ADB is isosceles triangles because it has two sides that are equal to each other. AB equals to AD. Okay? Again, triangle ABD is an isosceles triangles. Because it has two sides that are equal to each other. In triangle ABD, this triangle, we have AB that equals to AD. AB equals to AD, therefore triangle ABD is an isosceles triangle. Okay, this triangle is an isosceles triangle. And we have a rule that in any triangle that is isosceles triangle, if we have triangle ABC that is isosceles triangle, that is to say if triangle ABC is isosceles triangle, that is to say AB equals to AC, this side equals to this side, of AB equals to AC. So triangle ABC is an isosceles triangle. Then if we draw a perpendicular to BC, that is to say, this angle is a right angle, and this angle is also a right angle, and we define the contact point between the perpendicular to side BC. We define it as point D. This is point D. Then, according to this rule, whenever you have isosceles triangle and you draw a perpendicular from point A to side BC of the triangle, then according to this rule, BD equals to DC. BD equals to DC. Okay? BD equals to DC. Okay, again, whenever you have an isosceles triangle ABC, that is to say AB equals to AC, and you draw a perpendicular from point A to side BC of the triangle, then BD will be equal to DC. Okay, this line segment will be equal to this line segment. Okay. So actually we will implement this rule in our triangle. We will draw a perpendicular from point A to side BC of triangle ABC. So this is a right angle, and this is also a right angle, and we define the touching point between the perpendicular to side BC as point E. Again, the touching point between the red perpendicular to side BC of triangle ABC is defined as point E. Then, according to the rule that I mentioned a minute ago, BE will be equal to ED because of the fact that triangle ABD is an isosceles triangle. Whenever you draw a perpendicular to side, you will draw perpendicular to BD, then BE will be equal to ED. Okay? According to the rule that I mentioned, whenever you draw a perpendicular in an isosceles triangle, then BE will be equal to ED. Okay? So we can write down that BE equal to ED. And if we define BE as A, that is to say BE equals to A, according to the previous rule that I mentioned, in the isosceles triangle ABD, BE equals to ED, because whenever you draw a perpendicular in an isosceles triangle, then BE will be equal to ED. So if BE equals to A, then ED that equals to BE will be also equal to A. Okay, because we according to the previous rule, we know that BE equals to ED, and we defined BE as A. BE equals to A according to our definition. Therefore, DE also equals to A. From this equality, we can deduce that DE also equals to A. Okay, DE also equals to A. And okay, so we have ED equals to A and DC equals to 8 units, and BE also equals to A and ED equals to A. Okay, so actually in triangle AEB is a right triangle because angle AEB is a right angle. Again, triangle AEB is a right triangle. Okay, triangle AEB is a right triangle because of the fact we draw a perpendicular AE to triangle ABD. Therefore, this is a right angle and this is also a right angle. Therefore, because of the fact that in triangle AEB we have a right angle, therefore triangle AEB is a right triangle. Okay, so we can implement the Pythagoras theorem in the right triangle AEB, and according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AB squared equals to AE squared plus BE squared. Okay. Again, according to the Pythagorean theorem, in the right triangle AEB, the square of the hypotenuse, that is AB square, equals to the sum of the squares of the perpendiculars, equals to AE square plus BE square. Okay? And we know that AB equals to 8, so AB square is 64. AE, we will define AE as H, because actually AE is perpendicular to BD, therefore we define AE as H, so AE square is H square plus BE square. BE is defined as a, so be squared will be equal to a squared. So we got the equality that 64 equals to h squared plus a squared. I will mark it as equation number 1. Here we will subtract a squared from this equality, and we will get that h squared equals to 64 minus a squared. Okay, we got the equality that states that h squared equals to 64 minus a squared. Okay, and actually triangle AEC is also a right triangle because of the fact that angle AC is a right angle. Therefore, triangle AEC is a right triangle. Again, triangle AEC is a right triangle. Again, triangle AEC, this triangle is a right triangle because of the fact that this angle is a right angle. Therefore, triangle AEC is a right triangle. And we again can implement the Pythagorean theorem in the right triangle AEC, this right triangle. According to the Pythagorean theorem, the square of the hypotenuse, that is to say AC square, equals to AE square plus EC square. Okay, according to the Pythagorean theorem, AC square, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. AE square plus EC square. Okay, according to the Pythagorean theorem, AC square, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. Okay, but what is the value of AC? AC equals to 14 units. So AC square is actually 14 square. So 14 square equals to AE square. AE equals to H, so AE square is H square plus EC square. EC equals to A plus H, so EC square is A plus H square. Okay. Again, according to the Pythagorean theorem, in the right triangle AEC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. AC equals to 14, so AC square is 14 square. AE equals to H. AE equals to H according to our definition. And EC equals to A plus 8. So EC square is A plus 8 square. Okay. So here we got in equation number 1 that H square equals to 64 minus A square. So we can substitute H square by 64 minus A square because H square equals to 64 minus A square. So we will do it now. We'll substitute a squared by 64 minus a squared. Okay, we will substitute a squared in equation number 2 by 64 minus a squared. So 14 squared is 196 equals to h squared. H squared equals to 64 minus a squared plus a plus h squared. We will open the brackets. A plus h squared equals to a squared plus h squared is 64 plus 2 times a times 8 is 16a. Okay, so in total we got that 196 equals to 64 minus a squared plus 64 plus 16a. So here we have minus 6a squared plus a squared. It equals to 0. So a squared is cancelled. Then 64 plus 64 is 128. Okay, so we write it down. In total we will get that 196 equals to 128 plus 16a. Okay, so here we can subtract 128 from equation number 2. We will get that 68 equals to 16a. Okay, we got that 68 equals to 16a. Here we will divide this equality by 16 in order to get the value of a. So a equals to 68 over 16, that equals to 17 over 4. Okay, so we found out that the value of a, that is actually BE equals to ED equals to A, is actually, according to equation number 2, equals to 17 over 4 units. Okay, but we have equation number 1. Equation number 1 states that h squared equals to 64 minus a squared. Okay, according to equation number 1, h squared equals to 64 minus a squared, and we have already found out that a equals to 17 over 4, so we can substitute a squared in equation number 1 by 17 over 4. We will get that h squared equals to 64 minus 17 over 4 square, or h squared equals to 64 minus 17 square is actually 289. 17 square is 289, 4 square is 16. So in total we got that h square equals to 64 minus 289 over 16. And so h square equals to 64 times 16 is 1024. We took a common factor 16 for this equality. 124 minus 289 over 16. So h square equals to 1084 minus 289. So h square equals to 7035 over 16. Again, h square equals to 7035 over 16. So actually h square equals to 5 times 3 times 7 times 7 over 4 times 4. Again, we have h square that equals to 7035 over 16. So actually 735 is 5 times 3 times 7 times 7, and 16 is 4 times 4. Okay, so h equals to the root of 5 times 3 times 7 times 7 over 4 times 4. Here we can take out 7 and 4 out of the root, because the root of 7 times 7 is 7 and the root of 4 times 4 is 4. So here we will get that h equals to 7 over 4. 5 times 3 is 15 times root 15. Okay, so we got that h equals to 7 over 4 times root 15, and we have already found out that a equals to 17 over 4 units. Okay, so actually now we can find out the area of triangle ABC, because actually the area of any triangle, the area of any triangle equals to the base of the triangle times the height over 2. Okay, the area A is abbreviation for area, so the area of any triangle equals to the base of the triangle times the height to the base. The height must create 90 degrees with the base, and as you can see here, the height h indeed creates 90 degrees with the base BC. Okay? So the formula for the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of triangle ABC equals to the base of the triangle that is BC. BC is the base of triangle ABC, and the height must create 90 degrees with the base, so the height is AE, that is h, because AE creates 90 degrees with the base BC. Okay, AE times BC times AE over 2. So the area of triangle ABC equals to the base of the triangle that is BC times the height to the base that is AE over 2. BC times AE over 2. But what is the value of BC? The value of BC is actually A plus 8, or 2 times A plus 8. And what is the value of AE? AE equals to h according to our definition, over 2. So the area of triangle ABC equals to BC, that is 2A plus 8, times AE. AE equals to h according to our definition. So it is 2 times A plus 8 times h, that is the height of triangle ABC, over 2. But we have already found out that A equals to 17 over 4 and h equals to 7 over 4 times root 15. So the only thing that is left is to substitute h by 17 over 4 and substitute h by 7 over 4 times root 15, and to substitute a by 17 over 4 units. Okay, so we'll do it now. So the area of triangle ABC will be equal to 2 times A equals to 17 over 4, so 2 times 17 over 4 is actually 17 over 2. 2 times 17 over 4 plus 8 times the height, that is 7 over 4 times root 15 over 2. So the area of triangle ABC equals to 2 times 17 over 4 plus 8 times 7 over 4 times root 15 over 2. Here 2 over 4 is 2. We will have 2 in the denominator. So the area of triangle ABC will be equal to 17 over 2 plus 8 times 7 over 4 times root 15 over 2. Okay, so the area of triangle ABC equals to 17 over 2 plus 8 times 7 over 4 times root 15 over 2. So here we can put 8 here. We will get 16 over 2 plus 17 over 2. So the area of triangle ABC equals to 17 plus 16 over 2 times 7 over 4 times root 15. Okay, we got that the area of triangle ABC equals to 17 plus 16 is 33 over times 7 over times 2 times 4. Okay, so the area of triangle ABC will be equal all divided by 2, of course, (33) times 7 times root 15, 2 times 4 is 8, and 8 times 2 is 16. So actually we got that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so we got that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so this was the first method to find out the area of triangle ABC. Okay, now we will find out the area of triangle ABC in a second method. Actually, we know that the sum of the angles in any triangle is equal to 180 degrees, so we can say that angle A plus 2x plus x equals to 180 degrees, A plus 2x plus x equals to 180 degrees. Again, we got this equality according to the rule that states that the sum of the angles in any triangle equals to 180 degrees, and A plus 2x plus x is the sum of the angles in our triangle ABC. Okay, so here we have 2x plus x is 3x, so angle A equals to angle A plus 3x equals to 180 degrees. Here we'll subtract 3x from this equality, and we will get that angle A equals to 180 degrees minus 3x. Okay, so we found out the value of angle A. Angle A, this angle equals to 180 degrees minus 3x. Okay. And actually we have a rule that states that in any triangle if we have triangle ABC and the size of side AB is A units, the size of side AC of triangle ABC is B units, and the angle between side AB and side AC is theta. Then, according to this rule, the area of triangle ABC, this triangle, the area A is abbreviation for area, will be equal to A times B times sinus theta. A times B times sinus theta. Again, the area of triangle ABC equals to A times B times sinus theta. Okay, so actually we can implement this rule in our triangle ABC. So the area of triangle ABC, according to the rule that I mentioned, will be equal to 14 times A times sinus 130 degrees minus 3x. Okay, the area of triangle ABC will be equal to 14 times 8 times sinus of 180 degrees minus 3x. Okay, that is according to the rule that I mentioned, that the area of any triangle equals to the multiplication of its sides with sinus of the angle between those two sides. So the area of triangle ABC equals to, of course we must divide all by 2, so it is actually A times B times sinus theta over 2. Okay, the area of triangle ABC equals to A times B times sinus theta over 2. So here we will also divide 14 times 8 over 2 times sinus 180 degrees minus 3x. Okay, 14 over 2 is 7, and 7 times 8 is 56. So the area of triangle ABC equals to 56 times sinus of 180 degrees minus 3x. Okay, and we also have the trigonometric identity that states that sinus 180 degrees minus alpha equals to sinus alpha. So according to this trigonometric identity, that sinus 180 degrees minus alpha equals to sinus alpha, sinus of 180 degrees minus 3x equals to sinus 3x. Okay, so the area of triangle ABC equals to 56 times sinus of 3x. According to this trigonometric identity, it is sinus 3x. Sinus 3x. Okay, so that is the area of triangle ABC. We also have the law of sines. According to the law of sines, that is valid in any triangle. If we have triangle ABC, and the size of side AB of triangle ABC is A, the size of side BC of triangle BC is B, and the size of side AC of triangle ABC is C, and this angle is angle alpha, this angle is angle beta, and this angle is angle gamma. Then according to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. We actually can implement the law of sines in our triangle ABC. According to the law of sines, we can write down that 14 over sinus 2x will be equal to 8 over sinus x. Okay, so this equality is from the implementation of the law of sines in our triangle ABC. We know that sinus 2x equals to 2 sinus x cosinus x, so we'll write it down. So 14 over sinus 2x is 2 sinus x cosinus x equals to 8 over sinus x. Here we have sinus x in the denominator of this side of the equation. We have sinus x at the denominator of the other side of the equation, so we can cancel sinus x because we have sinus x on both sides of the equation. And 14 over 2 is 7, so 7 over cosinus x will be equal to 8. So from this equality we will get that cosinus x equals to 7 over 8. Again, we have the equality that states that cosinus x equals to 7 over 8. We will use the following trigonometric identity in order to find the value of sinus x. We have the trigonometric identity that states that sinus square of x plus cosinus square of x equals to 1. We will use this trigonometric identity in order to find out the value of sinus x, because we have in our equation sinus x. Actually, we found out that the area of triangle ABC equals to 56 times sinus 3x. Therefore, we must find out the value of sinus x in order to find the area of triangle ABC. So here we will subtract cosinus square x from this trigonometric identity. We will get that sinus square x equals to 1 minus cosinus square x. Here we will take a root out of this equality and we will get that sinus x equals to the root of 1 minus cosinus square x. Okay, but we know that cosinus x equals to 7 over 8. So we will square this equality in order to get the value of cosine square x. Okay, so cosine square x will be equal to 7 square is 49 over 8 square is 64. So we got that cosine square x equals to 49 over 64. Okay, cosine square x equals to 49 over 64. So here we can substitute cosine square x by 49 over 64, because cosine square x equals to 49 over 64. So we'll do it now. We will get that sinus x equals to the root of 1 minus cosine square x equals to 49 over 64. So we substitute cosine square x by 49 over 64. So in total we got that sinus x equals to the root of 1 minus 49 over 64. Here we can take 64 as a common factor of this expression. Instead of 1, we can write 64 over 64. So 64 will be a common factor. We'll get that sinus x equals to the root of 64 minus 49 over 64. So sinus x equals to 64 minus 49 is 15 over 64. Okay, we got that sinus x equals to root 15 over 64. The root of 64 is 8. So we'll get that sinus x equals to root 15 over 8. Okay, we found out that sinus x equals to root 15 over 8, and we have the equality that states that the area of triangle ABC equals to 56 times sinus 3x. The area of triangle ABC equals to 56 times sinus 3x. And we found out that sinus x equals to the root of 15 over 8. We know that the area of triangle ABC equals to 56 times sinus 3x. But what is the value of sinus 3x? The value of sinus 3x equals to 4 sinus square x minus 4 sinus cube x. It's actually 3 times sinus square x minus 4 times sinus cube x. Okay, so I think it is 4. So okay, so here we will take sinus x as a common factor of this expression. We will take out sinus x as a common factor of this expression, and we will find out that the area of triangle ABC equals to 56 times sinus x. We took sinus x as a common factor out of this expression. So here we will have sinus x minus so here actually sinus 3x equals to 4 sinus x, 4 sinus x minus 3 sinus cube x. So we took sinus x as a common factor. So in the brackets, what is left is actually 4 maybe it is 3 minus 4 sinus square x. Okay, so here we know that sinus x equals to root 15 over 8, so if we square this expression we will get that sinus square x equals to 15 over 64 . So here we will have that the area of triangle ABC equals to 56. Sinus x is root 15 over 8. And here we have 3 minus sinus square x is minus 4 times sinus square x is 15 over 64. So actually we get that the area of triangle ABC equals to 56 over 8 is 7. It is 7 times root 15. times 3 minus 60 over 64. So in total we got that the area of triangle ABC equals to 7 times root 15 times 3 minus 60 over 64. So here we have 4 times 4 over 64 is actually 3 minus 15 over 16. So the area of triangle ABC equals to 7 times root 15, 848 minus 15 over 16. So the area of triangle ABC equals to root 15 times 7. Here we have 33 over 16. 33 times 7 is 231. So the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so found out that the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, now I will summarize the lecture. Actually, we wanted to find out the area of triangle ABC count the R in two different ways. We actually draw line segment AD in such a way that this angle will be equal to 2x, like this angle. So here we have isosceles triangle. Triangle ABD is an isosceles triangle, and we have a rule that in front of isosceles, in front of equal angles, we have equal sides. So this angle equals to this angle, so this side must be equal also to this side. According to the rule, if you have two angles that are equal to each other, then AB must be equal also to AC. For that reason, we know that those two angles are equal to each other, therefore AD equals to AB, because of the fact that this is an isosceles triangle. Okay, so if this side is 8 units, then AD will be also equals to 8 units. So in the isosceles triangle, triangle ABD, AB equals to AD, AB equals to AD equals to 8 units. So we know that AB equals to 8 units, so we can deduce from this equality that AD also equals to 8 units. So AD equals to 8 units, and we also have the following rule that states that in any triangle, the sum of those two angles equals to the angle that is exterior angle. So this angle equals to the sum of those two angles. So the sum of those two angles is alpha plus beta. So this angle will be also, the exterior angle will be also equals to alpha plus beta. So we can implement this rule in our triangle ABC, because actually we have those two in triangle ADC. We can, according to the rule that I stated, those two, the sum of those two angles must be equal to 2x, or DAC plus DCA equals to 2x, DAC plus ADC plus ACD must be equal to 2x. DAC plus DCA equals to 2x. The sum of those two angles equals to 2x. So here we can subtract x from this equality. We will get that angle DAC equals to x. So this angle equals to x. So here we have two angles that are equal to each other in triangle ADC. Therefore, triangle ADC is an isosceles triangle. That is to say, those two sides are equal to each other. If we have two angles that are equal to each other, then in front of those two angles we have also equal sides. So AD must be equal to DC because of the fact that those two angles are equal to each other. Therefore, AD also must be equal to DC. But we know that AD equals to 8 units, so DC that equals to AD must be also equal to 8 units. Okay, and we know that triangle ABD is an isosceles triangle because it has two sides that are equal to each other, they're equal to 8 units. So if we draw a perpendicular from point A to BC, then BE will be equal to ED, because whenever you have an isosceles triangle, that is to say AB equals to AC, then according to this rule, BD also must be equal to DC. Therefore, the implementation of this rule in our triangle ABD, we have a isosceles triangle, that is to say AB equals to AC. Therefore, according to the rule that I mentioned, also BE must be equal to ED. And if we define BE to A, then if we define, so we know that according to the rule that I mentioned, BE equals to ED, and if we define BE as A, then DE also must be equal to A. Okay, so DE also equals to A and B equals to A. So in the right triangle AEB, AB square equals to BE square plus AE square, but we know that AB equals to 8 units, so AB square is 64, AE equals to 8, so AE square equals to 8 square, and BE equals to A, so BE square is A square. So from this equation number 1, we got that 8 square equals to 64 minus A square. Okay, but we also know that triangle AEC is a right triangle because of the fact that this angle is a right angle. So in the right triangle AEC, AC square equals to DC square plus AD square. Okay, in the right triangle AEC, AC square equals to AE square plus EC square, but we know that AC equals to 14, so AC square is 14 square, AE equals to 8, so AE square equals to 8 square, and EC equals to A plus 8. Again, EC equals to A plus 8, so EC square is A plus 8 square. But we know also from equation number 1 that H square equals to 64 minus a squared, so we can substitute h squared by 64 minus a squared, and we have only one variable that is missing, that is a. So we found out that a equals to 17 over 4 units, and now we have this equation number 1 that states that h squared equals to 64 minus a squared, and we have already the value of a, so we can find out also the value of h by substituting a squared in this equality by a squared, that is actually 17 squared over 4 squared. Okay, so h squared equals to 64 minus 17 over 4 squared, and we found out that h squared equals to 735 over 16, and actually we found out that h equals to 7 over 4 times root 15, and a equals to 17 over 4. So after we have the base of the triangle times the height equals over 2 over the base times the height over 2 equals to the area of triangle ABC. So that is the area of any triangle. The base times the height over 2 equals to the area of any triangle, and the area of triangle ABC equals to the base, that is actually BC, times the height, that is h, over 2, and we know that the base BC equals to a plus 8 or 2a plus 8, and the height of triangle ABC actually equals to 7 over 4, h equals to 7 over 4 times root 15, all divided by 2. So actually we have all the data inside the equation of the area of triangle ABC, and we found out that the area of triangle ABC actually equals to 231 times root 15 over 16 square units. Okay, so that was the first way to find out the area of triangle ABC. Then we found out the area of triangle ABC in a second way. Actually, here we have the rule that states that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in this triangle and in any other triangle equals to 180 degrees. Therefore, angle A plus 2x plus x equals to 180 degrees. Okay, angle A plus 2x plus x equals to 180 degrees. So here 2x plus x is 3x. So we found out that angle A equals to 180 degrees minus 3x. This angle is equal to 130 degrees, 180 degrees minus 3x. And we know that the area in any triangle equals to A times B times sinus theta over 2. So the area of our triangle will be equal, according to this formula, will be equal to 2 times A times B times sinus theta over 2 plus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 degrees minus 3x. So the area of triangle ABC equals to 180 14 times 8 times sinus 180 degrees minus 3x over 2. Okay, the area of triangle ABC will be equal to 14 times 8 times sinus 180 degrees minus 3x over 2. So the area of triangle ABC, 14 over 2 is 7, and 7 times 8 is 56 times sinus 180 degrees minus 3x. We know we have the equality that states that sinus 180 degrees minus alpha equals to sinus alpha, so according to this identity we can say that sinus 180 degrees minus 3x equals to sinus 3x. Okay, so instead sinus 180 degrees minus 3x, we can write down sinus 3x because they are equal to each other according to this trigonometric identity. Okay, so we got this equality for the area of triangle ABC. Triangle ABC, the area of triangle ABC equals to 56 times sinus 3x. Okay, and we have the law of sines that we used in our triangle. According to the law of sines, in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. So in our specific triangle ABC, we can say that 14 over sinus 2x equals to 8 over sinus x. Okay, 14 over sinus 2x equals to 8 over sinus x according to the law of sines. We know that sinus 2x equals to 2 sinus x cosinus x. We have sinus x in this side of the denominator, and we have in the denominator, and we have sinus x on the other side of the denominator, so we can cancel sinus x. After we cancel sinus x, we got that cosinus x equals to 7 over 8. So we know that cosinus x equals to 7 over 8. And we have the following trigonometric identity that states that sinus square x plus cosinus square x equals to 1. Here we subtracted cosinus square x from this equality, and we got that sinus x equals to the root of 1 minus cosinus square x. We know that cosinus x equals to 7 over 8, so cosinus square 8 will be equal to 49 over 64. So after we found out the value of cosinus square x, we can substitute cosinus square x by 49 over 64. So we substituted here it, and we found that sinus x equals to root 15 over 8. Okay, and we have the formula for the area of triangle ABC. It equals to 56 sinus 3x, and we know that sinus x equals to root 15 over 8, so sinus square x equals to 15 over 64, and the area of triangle ABC equals to 56 times sinus, the value of sinus 3x, it is actually 4 sinus x minus 4 sinus cube x, Okay, so we found out that the area of triangle ABC equals to 15 times root 15 times 231 over 16 square units. Okay, so that is the final answer. We found out in the second method that the area of triangle ABC equals to 15 times 231 over 16 square units. Okay, thank you very much.